we now look at we said looking at completing the square, and we did a sketch. So maybe we can do one more sketch. So we are looking at question 4. We are following the tutorial sheet. So this was tutorial sheet 4. Now we are on question 4. And in fact, we had skipped question 4. We went to question 7. Maybe we can do one more question here. Question 7. This is sheet 4. So please keep these solutions in your tutorial books. So do part 4. F of x is equal to negative 2x squared plus 11x minus 15. Complete the square. Find the maximum minimum value, sketch. To complete the square, we factor out 2, remain with x squared minus 11 over 2x, and keep the 15 aside. This means that we keep negative 2 here, half x squared minus 11 over 2x, and then add the half of 11 over 2 is the same as multiplying 11 over 2 by half, which will be 11 over 4. Then have it squared, subtract its very square. Close. Close. And then you bring back the 15. This means that negative 2 is still outside, as we get x minus, we now go to 11 over 4, have it squared, minus, we expand the 11 there, we get 121. If we square it, divide by 16, minus 15. Then expand the negative 2, so we'll get negative 2 multiplied by the brackets, squared, plus 121 over 8 minus 15. Remember, the 2 does not reach 15 because 15 is outside the brackets. Now we can simplify and get what 121 over 8 minus 15 is. 8 down, and then we'll have 121 minus 15 by 8, 15 by 8, 40, 8, 12, so 120. I think this question was solved, but anyway, it's all right. 1 over 8. Then we get negative 2x minus 11 over 4 squared plus 1 over 8. The square has been fully completed. What's remaining now is to sketch. Now to sketch, we need the y-intercept. Y-intercept. which is obtained by substituting 0 where there is x in f, so that we get a constant negative 15. So the intercept is 0, negative 15, like that. And then the next thing is the maximum or minimum value depends on the value of a. So a is negative 2. Remember, a is always the coefficient of x squared. So it's negative 2, which is less than 0. So what we must obtain is a maximum. And the maximum point is what we need when sketching, which is line of symmetry obtained, x minus 11 over 4 is equal to 0, so that we get x is equal to 11 over 4. So we have 11 over 4 for x, comma y, 1 over 8. Like that. That's the maximum point. Then from there, we get the x-intercept. That's the only thing remaining now. The x-intercept, where we equate this whole thing to 0. So the x-intercept, we equate negative 2 x minus 11 over 4 squared plus 1 over 8 to 0. Take this the other side. So we have negative 2 x minus 11 over 4 squared is equal to negative 1 over 8. Divide by negative 2 is the same as multiplying by negative half. So that this and that gets cancelled. Then we'll have x minus 11 over 4 squared is equal to 1 over 16. Get the square root, get the square root. So we'll have x minus 11 over 4 is equal to plus or minus 1 over 4. The square root of 16 is 4, of 1 is 1. That means that we have answered. Watson?
Yes, sir. Hello, sir.
Hello.
Hello. Sir.
Hello.
Hello. Yes,
Hello.
sir. Hello. There are times, sir, when after you equate the 1 over 8, now there are times when you get an irrational number, like maybe it's 41 in the square root. So how do you go about that?
You keep it as 41 in the square root and just approximate what it is.
Just approximate.
Look, if you have root 41, root 41,
Yes, sir.
we know that it lies between root 36, which we know, and root 49, which we know, is it?
Yes, sir.
This is 6, this is 7. So this number
Yes.
is 6 point something. So we use it as 6 point something.
Okay, sir.
Uh-huh.
So we
Yes.
guess, in other words.
We have not guessed. We have approximated.
Sir,
Hello.
I joined late. I didn't get what you were explaining from the beginning.
This is the question. And we are completing the scale. And now, are you now where we have reached?
Yes, sir.
Now, we are getting there. x-intercepts, which is you get x is equal to 11 over 4 plus 1 over 4, giving us 12 over 4, which is 3. The other one, it will be x is equal to 11 over 4 minus 1 over 4, which is 10 over 4, which is equal to 5 over 2. Then we sketch. What's important in our sketch are these intercepts. So 5 over 2 will be here, and then 3 there, and then the turning point is 11 over 4, so it will be here, 11 over 4, comma 1 over 8, so comma 1 over 8 there. And since you are saying it's maximum, what is the y-intercept? 0, negative 15. So it's going to pass through. It's going to pass through here. And go down like that. Assuming that this guy here is what is 3. And this one here is negative 15. This one carries marks, always. Good marks actually. Because you've seen the work involved. You complete the square, you get, in most cases, here you get 3 marks. And then when you sketch, you are given 1 mark for this point, another one for that point, for this one, and for that one. So you have 1, 2, 3, 4, plus 3, 7 out of 7. So that if you have messed up on the points, you lose marks for those points. And in fact, when you mess up with one intercept, then you have messed up with the whole sketch. Because you can't tell me that the sketch that passes through this, even if this was 3, this is 0. And this one is 11 over 4, comma 1 over 8. Don't tell me that these sketches are the same. They are very different. Just because of one intercept, it has affected another intercept. So if you err there, it means that you are in trouble. You are not supposed to. Should always be taking your time.
So, sir, it's okay if you leave it like that without giving it a name.
Without giving it a name.
Yes, as in you name the case or the parabola.
Ooh, this is the only thing that we have. So already we know this is f of x. Because naming of this is the same as saying question that you're moving with your f of x all the way up to here. Why should I name it when it's only that I'm sketching f? Automatically this is f. Okay. Next, so the next thing that we'll do now is, since we are able to complete a square and sketch, we should be able to understand what goes around with the, ax squared plus bx plus c is equal to 0. This guy, by computing the square or by the general formula, we know that x is obtained in this manner. Here we have two possibilities. You saw what was happening here. We had the plus here. We also had the minus here. This means that there are two options. Now, if we name the first option as alpha, then we'll have negative b plus the root of b squared.
Sir,
Hello.
what question are we doing?
We now want to move to question 5. We are from question 7.
Oh, all right. May you kindly just begin the explanation from x squared?
From here?
Yes.
Okay, thank you. So the quadratic formula, the quadratic equation is ax squared plus bx plus c is equal to 0. If they say use the formula to get the values of x, this is the formula that we use, is it? Now this formula has two options. It has a plus or minus. Now suppose we name the option that has a plus as alpha and the option that has a minus as beta. Negative b minus the root of b squared minus 4ac over 2a. We've named them. We want to try to understand how these relate. Let's see what we get when we add them. When we add them, they have a common denominator. Okay, let's be slow. We add them as this, b squared minus 4ac over 2a plus negative b minus the root of b squared minus 4ac over 2a. Then we get a common denominator 2a. Go all the way, we get this on top there, b squared minus 4ac, and then 2a into a, then we'll get negative b minus b squared minus 4ac. Now we are subtracting. We can see that this piece here and this one, they differ just by a sign, so they'll take care of each other. Then we remain with the negative 2b over 2a, giving us negative b over a. If we add them, let's see the product. That is, if we multiply them, we'll have negative b plus b squared minus 4ac over 2a multiplied by negative b minus the root of b squared minus 4ac over 2a Let's see what we get. Negative b times negative b, we get b squared. And then we'll have positive b, and then b squared minus 4ac. Excuse. Okay. Then another one, it will be minus b squared minus 4ac, and then minus open bracket. The root times root, the root will disappear, but the thing inside here will remain in brackets, over the denominator 2a times 2a, it becomes 4a squared. Then already we can see that this piece and this one here cancelling, and then we remain with b squared minus, we expand there, b squared, and then plus 4ac over 4a squared. Again, you see that this one and this one will go. We remain with 4ac over 4a squared. So this 4 and this 4 will cancel. So when the 4's cancel, you notice that the a and the a square will cancel. So we just remain with 1a from down. So what we have observed is that alpha plus beta is just the same as negative b over a. We've also observed that if you multiply the two, it's just the same as getting c over a. This is very, very, very important. Now let's see if this is true. Since we have an example here where we are finding the values of x, what was our quadratic? Let's check it. It was negative 2x squared plus 11x minus 15. So we write it somewhere here. It was negative 2x squared plus 11x minus 15. Suppose we equate it to 0. Like that. We are saying, according to this, it's telling us that if you add the roots, alpha plus beta, it's just the same as getting negative b over a. Now our negative b here would be negative 11 over negative 2, which is a, so we'd get 11 over 2. And that if you multiply them, we'd get c over a, which is negative 15 over negative 2, which is 15 over 2. Like that. Now, what is happening is, we know the roots. We have 3. We also have 5 over 2. Let's see if we add them. If it's true that we'll get this. Let's add 3 plus 5 over 2. Let's see if we'll get 11 over 2. 2 is a common denominator. And there's a 1 here. 1 in 2, you get 2 times 3, 6. Plus 2 in itself, 1. 1 by 5, we get 5. 5 plus 6, that is 11 over 2. Let's see, maybe it's just by coincidence. Let's see if the product also will come out the same. That is a 3 by 5 over 2, giving us 3 by 5, that's 15. 15 over 2. So we've seen that there's no lie here. Instead of, so we are able to know the roots. We're able to know the sum of the roots, even without knowing what the roots are. What's on?
Yeah, sir, I'm a little bit lost on how you get the 3 and plus the 5 over 2.
You don't have to be lost. When we are sketching this, we solved for 3 and 5 over 2 by equating the whole equation to 0. Then from there we went to this piece where we're understanding the relationship of the two roots. Now we have found that if you add alpha and beta, after naming alpha to be the one that has a plus and beta to be the one that has a minus, we've discovered that if you add them, it's the same as getting negative b over a of the normal equation. Now we've gone to confirm. Since we had the equation where we solved for these roots, and we found 3 and 5 over 2, which helped us stretch this curve here. Suppose we add them as our roots. Does it relate with what we have discovered here? That's our question. That's what we are doing. So I don't know if you understand now. So now that we have that, let's go to question 5. Let's go to question 5 and see what we get. If alpha and beta are the roots of x squared minus 4x plus 2 is equal to 0, find equations whose roots are, okay, this one you have gone, let's start with 4. Let's start with 4. Let's start with 4. Okay, I have a question from Maena. Is it Maena? Or let me say Manoa. What's the question?
No, it was the error, sorry.
Okay. So I said we should start with question 4. Even it is different from what I'm looking for. Okay. So let me just add one concept. If you look at, so now we know the sum, and we also have the normal quadratic. So ax squared plus bx plus c is 0. We've just discovered that alpha plus b, which is beta, is negative b over a, and that alpha beta itself is c over a. If we try to divide, because we have a 0 on the other side, we're able to divide throughout. We can divide throughout by a and get x squared plus b over a x plus c over a is equal to 0. But we've seen that c over a is what? C over a is the same as alpha beta. So if we left this the way it is, here we can put alpha beta. So we also want to put alpha beta here. How do we put it? If you look at what we have here, we have alpha beta is equal to, negative b over a. But what we have here is b over a. So let's go to alpha plus beta is equal to negative b over a and divide by negative 1. Divide by negative 1 so that we have negative alpha plus beta is directly equal to b over a. So we come here and say this, then can be written as x squared minus alpha plus beta x plus alpha beta is equal to 0. Very, very important. This means that by illustration, I give you a simple example. If alpha is 2, beta is 3, find the equation whose roots are those. Yours is to write this alpha plus beta x plus alpha beta is equal to 0, and say x squared minus 2 plus 3 x plus 2 by 3 is equal to 0, meaning x squared minus 2 plus 3, 5x plus 6 is equal to 0. So if you are given the roots and they ask for the equation, this is what you do to the roots so that they give you the equation. If you start from here and you solve for the roots, you for sure find 2 and 3. So that now we can freely go to question 4. Now, question 4 is the nature of roots. And let's go to question 5. I've got so many questions here: 4, 5, 6, 8, 9, 10, 11. Based on the same thing, 11, 12, and 13. All on one thing. Okay. So we can't go to any question yet. Let's extract some more information. So don't forget this. We are saying, kindly mute. Thank you. So don't forget this. Should we number them? This is 1. This is 2. We go to the other page. Notice that we said if ax squared plus bx plus c is 0, we could get the value of x using the formula over 2a. Now let's call d the inside thing. Let's call this one to be d. One thing you'll notice is that if d is equal to 0, we obtain equal real values of x, because it will just be x is equal to negative b over 2a, because the whole root thing there will be 0. So you have nothing to add and subtract. So that if d is greater than 0, we obtain 2 real distinct roots. And for sure, you can see that since here these are cases where the root could have 2 parts, where you would get 3 and 5 over 2. Those are real numbers. But if you are solving and you discover that the discriminant is less than 0, you know that you fail to get a real root. The only thing you say is that you obtain 2 distinct imaginary roots. These are the three cases that we have. And so whenever you check the discriminant, it gives you 0, then you know the nature of the roots will be real and equal. Okay, another question from Watson.
Sir.
Hmm.
Yeah, there are times when d is greater than 0, but the roots are irrational. So what do you say about that?
An irrational root is a real root.
Oh.
Mm.
Okay, so I get it.
Okay. Okay. Then now that we also know this part, we can now go back and attack question 4 up to question 13. Since we'll skip 7 because I've already done 7. So let's start question 4. When I say question 4, I mean of tutorial sheet 4. So question 4, without solving the equation, determine the nature of roots of the following equations. 1, 4x squared, 4x squared plus 20x plus 25 is equal to 0. When they say without solving, we don't mean don't write anything, no. The question says, without knowing the actual roots, can you tell the nature? Now, what tells us the nature is a discriminant. Because you are saying if it is 0, then you get equal real roots. If it is greater than 0, you get 2 real distinct roots. If it's less than 0, you get complex roots, imaginary roots. So here you just form the D. D is B squared minus 4AC. B is 20, have it squared, minus 4, A is 4, C is 25. This will be 400 minus 4 times 25, 100 by 4, another 400, giving us 0. So since it is 0, we get equal real roots. 2, so the job with us is as this thing that I'm doing. 2 x squared plus 4x plus 7 is equal to 0. Again, all we need is D, which is B squared minus 4AC. That is 4 squared minus 4. A is 1, C is 7. That is 16 minus 28, which is negative 12, which is less than 0. So we have imaginary roots. Okay, so the time you get greater than 0, then you have distinct roots. So that we go to question 5 now. So I've left 3 and 4 for you, but 3 looks like it's not arranged. So 3 is 16x squared is equal to 40x minus 25. So first we arrange it. This is equal to 0. And then get b squared minus 4ac, which will be negative 40 squared minus 4, 1625. And this is going to be 1600 here minus another 1600, which is 0. So again, equal real roots. Okay. So you should do 4, because normally you find that one you have left is the one that the examiner wants. So you should just do it when you're trying to see what's going on here. Question 5. If alpha and beta are the roots of the equation x squared minus 4x plus 2 is equal to 0. If alpha and beta are the roots of this, it means that alpha plus beta should be negative b over a of this equation. So negative 4 over a, which is 1, that is positive 4. Alpha beta c over a, c is 2, a is 1, which is 2. So we know the sum, we know the product. Find equations whose roots are 1, the roots are alpha plus 3 and beta plus 3. So remember, in our case here, we had assumed that the roots were 2 and 3, and this is how we found the quadratic. Now here, we've been given that the roots are alpha plus 3 and beta plus 3, so meaning that our equation will be found by subtracting. So let's write it in a smarter way. So you say, okay, the sum multiplied by x plus the product is equal to 0, where our sum is adding alpha plus 3 plus beta plus 3, giving us alpha plus beta plus 6. But alpha plus beta is here, and its value is 4. So 4 plus 6, giving us 10. Let's see, the product is alpha plus 3 multiplied by beta plus 3. So we get alpha times beta, that's alpha beta plus 3 alpha plus 3 beta plus 3 times 3, 9. So we get alpha beta is 2 plus we factor out the 3 so that we can see that this is alpha plus beta plus 9. So we have 2 plus 3. Alpha plus beta.
Sir,
Hello?
I'm kind of lost from the beginning where it says x squared minus 5x. I don't know
Minus
if that
4x.
is plus 3.
Oh no,
Somewhere
this
here.
is S.
It's s. Huh?
Yeah, so we're coding the sum as S.
Okay.
So we're supposed to write this. We're supposed to write this. Now,
All right, sir.
so what you're coding S is alpha plus beta. What you're coding P is alpha beta.
All right, I've seen. Thank you.
Okay. So that the alpha plus beta is known is 4 plus 9. And so we get 2 plus 12, that is 13. 18 plus 9. That's what? 23.
Sir,
Hello?
me, I'm lost. Yeah, this 4 plus 6 is 10. Where is the 4 coming from?
So look, here
Oh,
we have
from
alpha plus beta.
yes.
And what is alpha plus beta?
Oh, 4. Oh.
4. So I'm adding here 11 plus 12. Yeah, it's 23. It's 23. Yeah. So now we have the sum. We also have the product. So our equation then will be x squared minus our s is 10 x plus our p is 23, which is equal to 0. So this is our equation, whose roots are alpha plus 3 and beta plus 3. B, part 2. The roots are alpha plus 3 beta and beta plus 3 alpha. We need to find the equation whose roots are those. So, but we know that the equation should be x squared minus the sum of those roots multiplied by x plus the product is equal to 0. Now the sum is alpha plus 3 beta plus beta plus 3 alpha, meaning alpha plus 3 alpha, we get 4 alpha. 3 beta plus beta, we get 4 beta. Factor out 4, we remain with alpha plus beta. But we know what alpha plus beta is 4. So this is 16. We keep it as we look for the product, which is alpha plus 3 beta multiplied by beta plus 3 alpha. Alpha times beta, we get alpha beta, plus alpha times 3 alpha, we get 3 alpha squared, plus 3 beta squared, plus 9 alpha beta. Now alpha beta plus 9 alpha beta, this is the same as 10 alpha beta, plus factor out a 3 and get alpha squared plus beta squared. Now here, when you are looking for alpha squared plus beta squared, remember we don't know what this is. What we know is alpha plus beta to be 4, and not when they are squared. So you need to look for a relationship of the squared in terms of the sum and the product, if possible. So get alpha plus beta and square it and see what it will give us. It will give us, this is the same as alpha plus beta multiplied by alpha plus beta, which is alpha squared plus alpha beta plus alpha beta plus beta squared, giving us alpha squared plus beta squared plus 2 alpha beta. Now this thing on the left, it is alpha plus beta squared. Now if you look at this properly, you notice that that this guy here is known, that this guy also is known. Alpha beta is actually known to be 2. So if we take this side, we'll have alpha plus beta squared minus 2 alpha beta, giving us alpha squared plus beta squared. So what we are saying is that this is the identity that we must be using whenever we are looking for this. Meaning, when you go back to our question, where there is alpha squared plus beta squared here, we'll bring it after evaluating this. So what is alpha plus beta? It is 4. So we have 4 squared minus 2. What is alpha beta? Is 2. But this is 16 minus 4, which is 12. This 12 is alpha squared plus beta squared. Now we can go back to our question and get, this is 10. Alpha beta is known to be 2 plus 3 multiplied by alpha squared plus beta squared. We have found it. It's 12. So we put 12 here, which is 20 plus 24. 20 plus 36. 20 plus 36, which is 56. So we go back to our sum here and write our equation. It will be x squared minus 16x plus 56 is equal to 0. That's how you come up with the equation. So you must always keep that formula, the x squared minus the sum x plus the product is equal to 0, and know what that and know that what you're calling s is just the sum. What you're calling p is just the product. So that is answering question 5. Okay, so slowly we are doing our notes, combining the tutorial sheet, so that by the time we are through with it, we have no question left unattended to. We now go to question 6. Question 6. Question 6 is find two numbers. Question 6a. Find two numbers whose sum is 16. Find two numbers x and y that when you add you get 16. Whose product is maximum? Whose product xy is maximum? In everything that you have done here, that day, when you are looking at the completing the square, I made mention that the value that we call the line of symmetry gives us a maximum or minimum value, depending on the value of A. So, since we have the product, we also have the sum. If we go back to the sum and solve for y, it will come out to be 16 minus x. Then we come to the product and write it as a function of x. Since where there is y, we are bringing 16 minus x. You will notice that we are getting 16x minus x squared, which you can write as negative x squared plus 16x. This means that our A in this case, our A is -1. So we'll have a maximum at x is equal to -b over 2a, which is -16 over 2 by -1, which is equal to -16 over -2, which is 8. This is the x value. But since we know that y is 16 minus x, then we'll have 16 minus 8, which is equal to 8. So we have found the value of x and y. So we have found two numbers whose sum is 16 and the product is the maximum. If the numbers are small, like the way it is, like the way this 16 is small, you could actually try it. You say, okay, I'm looking for two numbers. When I add 16 plus 0 will give us 16, but the product 16 by 0 is 0. 15 plus 1 will give us 16, but the product 15 by 1 is 15. 14 plus 2 will give us 16, but 14 by 2 gives us 28. 13 plus 3, 13 plus 3 gives us 16, but 13 by 3 gives us 39. 12 plus 4 will give us 16, but 12 by 4 gives us 48. 11 plus 5 gives us 16, but 11 by 5 gives us 55. 10 plus 6 gives us 16, but 10 by 6 gives us 60. 9 by 7 gives us 16, but 9 times 7 gives us 63. 8 plus 8, so this is plus here. 8 plus 8 gives us 16, but 8 by 8 gives us 64. If you go down, you have 7 plus 9 will give us 16, but 7 times 9 will give us 63. Meaning that you've now said going back. We'll just be switching the numbers until we get there. So the only two numbers giving us 16 and have the maximum product, we've seen that is 8 and 8. Now you can only do that if the sum is small. But what if the sum is too big? Maybe they say the sum is 1000. You can't manage doing all that. But you can easily change it into quadratic and then deal with the properties of maximum and minimum value around the line of symmetry x is equal to -b over 2a. Okay. Then B, for the same question, 6. A man with 180 fencing wishes to fence off an area in the shape of a rectangle. Shape of a rectangle is something like this, where this is x, this is y, this is x, this is y. So what should be the dimensions of the area if the enclosed space is to be as large as possible? Now you understand that the fencing is 180. So 180 is the perimeter. And the perimeter of a rectangle is by adding, which is the same as 2x plus 2y. So this is a perimeter, 2x plus y. But since it is known, 2x plus y, we are told it is 180. If we divide by 2, we'll get x plus y, 180 over 2, which is 90. And then the area of a rectangle is x multiplied by y. You know how we find, we just multiply the length by the breadth. Now we want this as large as possible, meaning if we solve for y again, we force it to be quadratic, then the area will be a function of x, which is x multiplied by 90 minus x, giving us 90x minus x squared, which is negative x squared plus 90x. When we get there, our next step will be looking for x. That gives us maximum, which is negative b over 2a. So negative 90 over 2 negative 1. This is the same as negative 90 over negative 2, which is positive 45. So that now y also can be found as 90 minus 45, which is also 45. So the dimensions should be 45 by 45. Meaning that this rectangle will be that special rectangle, which is a square. That will be a rectangle that we're going to obtain. That special rectangle, which is so let's see how we get those dimensions there. This was question 6. Question 7, I already answered the maximum and minimum there. So let's go to question 8. Question 8, suppose that the equation px is equal to negative 2x squared plus 280x minus 1000, where x represents the number of items sold. Describe the profit function for a certain business. So this px describes the profit function for a certain business, where x represents the number of items sold. The question is, how many items should be sold to maximize the profit? So what value of x should we obtain if we want to get the maximum profit? But you understand that we said for n quadratic, the value of x, negative b over 2a, gives the maximum or the minimum value. Depending on the value of a. So in this case, a is equal to negative 2, which is less than 0. So x is equal to negative 280, which is b, over 2 by negative 2, which is negative 280 over negative 4. This is plus, and then we get 70 there. So this is what will give us, this will give the maximum profit. That was 8. 9 is similar. The height of a projectile fired vertically into the air, neglecting air resistance at an initial velocity of 96 feet per second is a function of time x and is given by the equation f of x. So the height is a function. F of x is equal to 96x minus 16x squared. We're able to write this as negative 16x squared plus 96x. Find the highest point reached by the projectile. We're not being asked to find the x which gives us the highest. We are asked to find the actual highest.
It's
Hello.
I have a question on number 8. Sorry to take you back. So where we said a is equals to -2 is less than 0. So does it mean that when a is negative or less than 0, then it's a maximum?
Always.
All right.
Yes. And when a is greater than 0, it is a minimum.
It's a minimum. All right.
So already we know that on question 9 here, since a is less than 0, the height being talked about here is the highest that can be obtained. And we are saying find the highest point, not find the x which gives the highest point. No, we want the highest point. So the highest point, remember a point is x comma y, where the x is a line of symmetry, comma the y, the maximum value. So if you have forgotten the formula, but the formula is here negative b over 2a, comma 4a, have I forgotten also? Comma negative b squared over 4a plus c. This is the formula for the maximum minimum point. Now, if you have forgotten this, you can as well just find x negative b over 2a, which is negative 6. And that's why it's nice to rearrange here. Because I've rearranged, I've realized that I can make a mistake. So negative 96 as our b over 2 negative 16. This means that if you use 2 here 1, 2 there 4, remainder 1, 2 there 8. So we get 48 over 16. 16 in 48, 3. So if we get 3 and take in f, which is 96 by 3 minus 16 by 3 squared, giving us 96 by 3 minus 16 by 9. So what is 96 by 3? That is 18, carry 1, 27, 28. So we get 288 minus 16 by 9, 9 by 6, that's 53, 54. So 4 carry 5, and then 9 there, 144. So we get 144, giving us 144 altogether. So the point will be 3, 144. This will be the highest point reached. So you must be able to differentiate the question. The other question was asking us to give the number of items to be sold for us to get the maximum profit. And X was described as the number of items. So to find X, you just get the line of symmetry. Not that 70 is the maximum, no. It is the value of X that gives us the maximum. Here is the highest point. Let's go to the next one. This was 9. We go to 10. The roots of equations 2x squared minus 4x plus 5 is equal to 0 are alpha and beta. So before you start finding the value of the given things, you first find alpha plus beta, since you are told that the roots of this equation, which is negative b over a, which is negative 4 over a, which is 2. So you get 4 over 2, which is 2. You get also alpha beta, which is c over a, which is 5 over 2. So you have this. So when you get these, you realize that part 1 is asking us to find 1 over alpha plus 1 over beta. These are fractions, so we get the common denominator. Alpha and alpha beta, we get beta plus alpha there, but this is the same as alpha plus beta over alpha beta. But alpha plus beta is 2, and alpha beta is 5 over 2. This is the same as 2 over 1 multiplied by 2 over 5, which is 4 over 5. 2 asking us to find alpha plus 1 multiplied by beta plus 1. This is alpha beta plus alpha plus beta plus 1. But alpha beta is known, it is 5 over 2 plus alpha beta is 2 plus 1. That is 5 over 2 plus 3 over 1, 2 down, and then 5 plus 6, which is 11 over 2. And then 3, alpha squared plus beta squared. Remember we said whenever you find this, you must bring in this minus 2 alpha beta. I think we derived this. We derived this here. So once you derive it once, the remaining things is just remembering what it is. And alpha plus beta is 2 squared minus 2, 5 over 2. That is 4 minus 5, which is negative 1. You go to 4. 4 is alpha squared beta plus alpha beta squared. This is the same as alpha beta is common, so we remain with alpha in the first place and beta on the second place there. But alpha beta is 5 over 2 multiplied by alpha plus beta is 2. So we get 5. So we can get anything that they ask us to get. 5 alpha minus beta, then they square it. So we expand it. It will be alpha squared minus alpha beta minus alpha beta plus beta squared, which is alpha squared plus beta squared minus 2 alpha beta. But we've already found this. It's here. And it's -1. So -1 minus 2 alpha beta is 5/2. So we get -1 minus 5, which is -6. So we write -6. But if you didn't know what this is, then you replace it by alpha plus beta squared minus 2 alpha beta, and then bring the other minus 2 alpha beta. When you put these together, you get alpha plus beta squared minus 4 alpha beta, and then substitute, you still get to -6. So that 6, 7, and 8, I give you an exercise and see if you can relate. So there's nothing strange there. When you put your things together to get a common denominator, you'll be, the highest power will be 2. Let's go to question 11. Find the value of k so that the equation 1, 2x squared plus kx minus 15 is equal to 0 has 3 as one of the roots. So whenever you are given a root, it must satisfy the equation when you take it where there is x. So where there is x, you substitute 3. This must be satisfied. So we get 2 by 9, which is 18, minus 15 plus 3k is 0. So we get 3 plus 3k is equal to 0. This means 3k is equal to -3. Divide by 3, divide by 3. K is equal to -1. Two, we have 3x squared plus kx minus 2 is equal to 0 has roots whose sum is equal to 6. So the roots has sum equal to 6, but the sum is -b over a must be equal to 6. But b is k and a is 3 is equal to 6. This implies that -k is equal to 18. Divide by -1 by -1, we get k to be -18. Like that. 5x squared minus, is it 5x squared? Yeah, minus 8x minus 8x plus k is equal to 0 has roots whose sum is 1/5. I mean, whose product is 1/5. I'm used to the sum, whose product is 1 over 5. So we know that the product is alpha beta. It's been given as 1 over 5. When we know that it is just C over A, that should be 1 over 5. But C is K, A is 5, is equal to 1 over 5. If you cross multiply, we will get 5K is equal to 5 divided by 5 divided by 5. So K is equal to 1. Like that. So don't get tired. We are preparing for the exam, so we must be spending almost the whole day doing our schoolwork. Nothing like I want to do my hair. Nothing. Let those people who are home cook for you. 3x squared minus 5x plus 8 is equal to kx. Has roots numerically equal but opposite in signs. When you say numerically equal, you mean if alpha is 3, beta should be 3. Opposite in signs, if alpha is 3, beta should be -3. Meaning that if you have alpha, the other one should be negative alpha. But this is not in the standard form of the quadratic. So you must write it as 3x squared minus 5 minus k, here to be plus, and then the x outside. So because your brains are have been thinking for some time now, let me be slow. So 3x squared minus 5x minus kx plus 8 is equal to 0. This is 3x squared minus, you can now factor out x since it's common there and take it outside. 8 is equal to 0 to help us know A, B, and C. Now I've said numerically equal, so if you have alpha, instead of writing beta, you just write negative alpha, since they're all alphas except that they differ by a sign. So that if you add them, alpha plus beta, you must get negative b over a, which is negative 5 plus k over a, which is 3. This means that alpha plus beta, which is known as, here we know it is alpha plus, the beta is negative alpha. So this is 0, giving us 5 plus k over 3. If you cross multiply, the 3 will disappear, and we'll get k is equal to -5. That's how you get that value of that guy. We're just remaining 2 questions, 12 and 13. Question 12. Find the range of values of k so that the equation 1, 3x squared minus 4kx plus k is equal to 0 will have real roots. So remember, the real roots comes from where? It comes from the distance. It comes from here. So the nature of the roots, you require D, which is the discriminant, equal to 0, equal roots. Greater than 0, real distinct. Less than 0, imaginary. So that if it is greater or equal to 0, you have real roots. We are not just sure if they are equal or they are distinct. Meaning we've combined 1 and 2. So now, where we are looking at this, it must have real roots. So we require that b squared minus 4ac should be greater or equal to 0. But b is 4k squared minus 4, a is 3, c is k. This must be greater or equal to 0. So we get 16k squared minus 12k greater or equal to 0. Factor out k, we remain with 16k minus 12 greater or equal to 0. So we get critical values, k is equal to 0 and 16k minus 12 is equal to 0. Remember that we said whenever it's a product, use the table. Whenever it's a fraction, use the table. So we have a product. So to use the table, we need to get the critical values. 12 over 16 is the same as 4 there, 3 over 4. So we have 0. We also have 3 over 4. The middle number will be 3 over 8, meaning I add the 2 and divide by 2, since there's no whole number in between here. And then 1 is bigger than 3 over 4. Negative 1 is less than 0. Then we need k here. We also need 16k minus 12. We also need k by 16k minus 12. We have this. So we take negative 1, we get negative, negative, plus. Then we take 3 over 8 there, we'll get positive. Then we get negative, which is negative. Take 1, we get positive, positive, which is positive. We said whenever it is greater or equal to 0, we said we get what? The positive. So the solution set here is going to be negative infinite all the way up to 0, included, union, include 3 over 4, go all the way up to infinite. So 1 was just that. 2, kx squared plus 4 root 3 x plus k is equal to 1. We'll have imaginary roots. So first we write it as a normal quadratic. 4 root 3x plus k minus 1 is equal to 0. And say b squared minus 4ac should be less than 0. B squared, that is 4 root 3 squared minus 4. A is k, c is k minus 1. This must be less than 0. So 4 squared, that's 16. Root 3 squared, that is 3. Minus 4 k squared minus k less than 0. So we get 48 minus 4k squared plus 4k less than 0. Divide by 4. Divide by 4. So we get negative k squared plus k plus 48 divided by 4, that's 12 less than 0. Have this factorized as negative k squared. The product is negative, so we allow 4 to be positive and 3 to be negative, less than 0. So factor out negative k, we'll get k minus 4. Factor out negative 3, we'll get k minus 4. So that k minus 4, and then negative k minus 3 is less than 0. So k is 4, and also k is negative 3. Testing, we have negative 3, we have 4, 5 bigger, 0 in between, negative 5 smaller, and then k minus 4, and then negative k minus 3, and then the product, I'll just say tk. We test. So I'm looking for the signs. Let's hunt for them. When k is negative 5, this will be negative. This will be positive. So we'll get negative altogether. When k is 0, this will be negative. This will be negative. So we'll get positive altogether. K is 5. This is positive. And this is minus. So we'll get minus altogether. It's less than. So we need the solution set, which is negative. So from negative infinity all the way up to negative 3, union 4 to positive infinity. This is our solution. Adults question 12A. What's of 12B? 12B, find the range of values of k or value of k so that the quadratic function in the following satisfies the given conditions. So that the quadratic function satisfies the given conditions. Condition 1, that this quadratic 3x squared minus 9x plus k will touch have a vertex on the x-axis. Now an illustration of this is saying x, it will touch the x-axis. It must touch and not cross. So it will touch, make sure that it touches. It will touch the x-axis. It won't cross it. It will just touch. Meaning the only x value that you can find there, I mean, you can only find one x value. When you're looking for the x-intercept, you only find 1. And when do we find 1? When the roots are equal. Meaning, when the discriminant is equal to 0. So you get negative 9 squared minus 4. A is 3. C is k. This must be equal to 0. So 36 minus 12k is equal to 0. This should be a hand. Hastings.
Yes, sir. I would like you to repeat your explanation on vertex part.
So when they say a vertex, have a vertex, they mean it's a turning point on the x-axis. So it can be maximum or minimum. Our interest is if we solve for the x values where the graph touches the x-axis or cuts, we only get one value, meaning that we only have one real root. And when we have one real root, when the discriminant is equal to 0. If they said it will cut, meaning it will have two, so we'll have two x values, meaning if it touches, then they are real. So we'll have distinct real roots. If it does not touch, then we know when it does not touch is when we don't have the x-intercepts. When the discriminant is an imaginary number. So let's see now here we're saying it touches. It has a vertex on the x-axis. So we're saying the discriminant must be equal to 0, meaning negative 12k is equal to negative 36 divided by negative 12 divided by negative 12. So k is equal to positive 3. So only this value of k will give us that guy there touching the x-axis. Okay, let's see. 2. So I'll put 2 here. 2 x squared plus 2kx 3 over 4 minus k. Julius.
Yes, sir. Was that 6 squared or 9 squared?
9 squared. When it's 9 squared, what do we get? We get 81, is it? So that we have 81, so that we get 81 over 12. Okay, that's a good observation there. Okay. If we can divide this looks like it can be reduced by 3. Let's reduce it. How many times does 3 go in 81? 3 goes in 8 twice, leaves the remainder 2 in 21, 7 over 3 goes there 4 times. So it must end here. Yeah, okay. We have another one. We're looking for the values of k where this will not intersect the x-axis. So it will not touch the x-axis anywhere. Meaning, this only happens when the discriminant is less than 0. So when 2k squared minus 4, 1, 3 over 4 minus k is less than 0. Meaning 4k squared minus 3 plus 4k is less than 0. So minus 3 because when you multiply 4 by 3 over 4, these guys here will cancel. So it has become an inequality again, and it's a quadratic, so you must factorize it as a quadratic. 4k squared plus 4k minus 3 less than 0. So we have 4 by 3, that's 12. And 4, I mean, in fact, it's negative 12. So meaning that we'll have 4k squared. Which one must be negative? Negative 2k plus 6k minus 3 should be less than 0. So that 2k out, 2k minus 1 3 out, 2k minus 1 less than 0. So we get 2k minus 1. We also get 2k plus 3. So k is 1 over 2. K is negative 3 over 2. So we have negative 3 over 2. We also have 1 over 2. So 0 is in between. 1 is bigger. And negative 3 is bigger. Is less than any. So we get 2k minus 1. We also get 2k plus 3. And then let me equate just the product, px. So we have this. Okay, so when you have negative 3 there, we'll get negative. We'll get negative, giving us positive. When you have 0, we'll get negative, positive, negative. When you have 1, we'll get positive, positive, positive. One word is less than 0, so the solution set is going to be negative 3 over 2, comma half. Okay. Let's go to the third one. Four x squared plus 4 root 2k x plus k plus 3 will intersect the x-axis in 2 real points. So now the discriminant here must be greater than 0 for us to get 2 real values of x. B is 4 root 2k. It must be squared minus 4. A is 4. C is k plus 3. And it must be greater than 0. So we get 16 by 2, which is 32 k squared minus 16k minus 16 by 3, that is 48, greater than 0. Divide throughout by 16, and there by 16, we'll get 2k squared minus k minus 3 is bigger than 0. And then 2 by 3 gives us negative 6 as a product. So the only two numbers we can use here are positive 2 and negative 3. So that 2k is common as we remain with k plus 1. And minus 3 is common as we remain with k plus 1. So that k is negative 1. At the same time, k is 3 over 2. Have the test. A number in between here will be 0. After will be 2. Less than will be negative 2. And then we are testing 2k minus 3 and k plus 1, and then the product. So we get what do we get? By getting negative 2 here, we get negative, positive. 0, negative, positive, negative. 2, positive, positive, positive. We want where it's greater than 0, so we get the positive, positive. So the solution set is going to be negative infinite all the way up to negative 1, not including any union. Start from 3 over 2, go all the way up to positive infinity. This is our solution. So we're now getting to enjoy the properties of this, as 4 is asking us to show that there are no real values of x and y such that 1 over x plus 1 over y is equal to 1 over x plus y. No real values. This requires that the discriminant must be less than 0. Then you say there are no real values. Okay? For which that is true. So let's try to cross multiply things here. So first, xy as a common denominator will give us y plus x is equal to 1 over x plus y. Cross multiply, we'll get y plus x plus y is equal to xy, giving us xy plus y squared plus x squared plus xy is equal to xy. If this xy jumps the other side so that we form a quadratic, we'll get xy minus xy is equal to 0. So that this gives us a 0. We remain with x squared plus xy plus y squared is equal to 0. Suppose x is our variable. Then a will be 1, b will be y, and c will be y squared. So we'll have a discriminant b squared minus 4ac is equal to y squared minus 4a is 1 and c is y squared, giving us y squared minus 4y squared, which is equal to negative 3y squared. But this guy will be less than 0 for all values of x and y. Any value of y you take there, you will square it first before you multiply by the negative. So it always be negative, meaning that there will be no real value of x for which that thing is going to be true. So the discriminant is negative, which only happens when you have complex roots. Then question 13. Write down and simplify the equation whose roots are the reciprocals of the roots of 3x squared plus 2x minus 1 is equal to 0. What we mean here is, suppose alpha and beta are the roots of this. We know that this must give us negative 2 over 3. And alpha beta should be c over a, which is negative 1 over 3. Then what is happening? We are getting we want an equation of this nature, sx plus p is 0, where the s is coming from 1 over alpha, which is the reciprocal of alpha, 1 over beta, the reciprocal of beta, but this is just alpha beta, alpha plus beta, which is negative 2 over 3 over negative 1 over 3, which is negative 2 over 3 multiplied by negative 3 over 1, which is positive 2. And then the product, 1 over alpha by 1 over beta, giving us negative 2 over 3 by negative 1 over 3, which is positive 2 over 9. So go back here and say x squared minus the sum is 2x, and the product is 2 over 9 is equal to 0. If they demand for the integer coefficients, you multiply everything by 9, so that you get 9x squared minus 18x plus 2 is equal to 0. This is the equation that they are demanding, and we have given them. It's here. Okay, so we have exhausted our 2 hours. This means that we cannot talk about question 14. It's a different concept altogether, so you may get mixed up. Though it's not that different, but then it's important that you also talk about it with a fresh mind, where we do the computing the square, sketch the quadratic, and then pick the positives. If the modulus is positive, and if it's negative, pick the negatives, just like that. So we can end here. Have a good evening.
Thank you, sir.